Can new scientific ideas transform humanity into an advanced scientific civilization? In 1945, when space travel still seemed like science fiction, British writer and futurist Arthur C. Clarke presented a revolutionary idea in his article, Extraterrestrial Relays. He proposed that 3 satellites placed in geostationary orbit, approximately 35,786 kilometers above the Earth, could transmit radio and television signals across most of the world. At that time, not even a single artificial satellite had been launched. However, after the Soviet Union launched Sputnik 1 in 1957, the American space program gained momentum. Communication satellites such as SCORE, ECHO, and Telstar subsequently reached space. Finally, in 1964, SYNCOM-3 became the world's first successful geostationary communications satellite. Thus, in less than 2 decades, Clarke's futuristic vision began to turn into technological reality. This teaches us that imagination is often the first step towards the inventions of the future. Countries around the world have repeatedly demonstrated how learning, investment, and long-term planning can build scientific strength. China offers one notable example. Its modern research and development journey gained decisive momentum following Deng Xiaoping's reforms in 1978. China learned from the universities, laboratories, and scientific systems of the United States and other developed countries. It then strengthened its scientific capabilities through initiatives such as the 863 program, the Torch program, and the 973 program, along with overseas education, the return of scientific talent, industrial development, and steadily increasing investment. Its strategy was clear: first learn, then adopt, improve, and ultimately compete through its own technological capabilities. Today, millions of students, scientists, engineers, and independent thinkers across the world may have ideas capable of transforming humanity's future. But are they receiving adequate funding, research grants, access to modern laboratories, expert guidance, and the freedom to experiment? Governments, universities, research institutions, and international scientific organizations should present clear and ambitious roadmaps for the future. These roadmaps should identify long-term research priorities, funding requirements, timelines, and measurable objectives. Humanity's goal should not be limited to technological competition among countries. Nations must also cooperate to create new scientific fields capable of addressing common challenges, such as climate change, resource scarcity, planetary protection, long-duration space travel, and the long-term survival of civilization. Inspired by the visionary spirit represented by Arthur C. Clarke, an Indian author has presented several futuristic engineering concepts in his science fiction novel Race for a New World, which is available on Amazon. The novel introduces a bold, speculative field called gravity engineering. This imagined discipline explores the long-term possibility of understanding, simulating, and perhaps one day harnessing gravitational effects for advanced applications in space. Although gravitational manipulation remains far beyond present scientific capabilities, the concept invites us to consider how physics and engineering might eventually converge to redefine humanity's presence beyond Earth. One practical direction associated with this vision is the development of rotating space habitats that produce the effect of artificial gravity through rotation. Unlike the direct manipulation of gravity, this approach is based on established physics. Such habitats could help protect astronauts from the harmful effects of prolonged microgravity on their bones, muscles, balance, and cardiovascular systems. They could therefore make long-duration space missions and permanent human settlements beyond Earth more viable. The broader concept of gravity engineering also encourages deeper scientific inquiry into the behavior of gravity at different scales. Could future discoveries allow humanity to create
alter, or control gravitational environments in ways that appear impossible today? No existing technology can presently manipulate gravity in this manner. Nevertheless, carefully identified speculative ideas can generate questions, inspire experiments, and encourage new directions in fundamental research. Similarly, the novel calls for discussion about several other futuristic engineering domains and their possible relevance to humanity's future. The future will belong not merely to individual countries that adopt today's technologies, but to a humanity capable of imagining and responsibly developing the technologies of tomorrow. The question now is, will the world have the courage to transform bold scientific ideas into serious research questions and shared international objectives? Will governments, universities, and scientific institutions create roadmaps that inspire researchers, engineers, and students to explore entirely new frontiers of knowledge? Will nations compete only for technological supremacy, or will they also cooperate to address the challenges shared by all humankind? And will the people of the world be inspired to understand, support, and participate in the pursuit of these new scientific objectives? That remains to be seen.